Here we have an example of solving an inequality in one variable. You'll notice that we have only one variable x. Sometimes it'll be represented by a or b. Any variable is fine. If you see something that says solving in two variables, that's typically x and y, and you're going to have to graph a line at the end. Now, because this is one variable, this is going to be a little bit simpler. We're going to graph our final answer on a number line. If we had two variables, we need a two-dimensional space, an x and a y axis. But for now, we're going to keep it simple. Solving an inequality is just like solving an equation. We're going to treat our inequality symbol, our less than, just like an equal sign. And I'm going to actually divide this in the middle. So we are treating this less than like the equal sign. This is technically the middle. We know that no matter what number we put here for x, this whole thing better be less than 30 because that's what it's telling me right here. We're going to follow the same steps as if we were solving an equation. There's only one difference between an equation and an inequality, and I'll tell you what that is as we get towards the end of our problem. But we're going to pretend this is an equation. Whatever you do to one side, we do to the other side, and we're going to start by getting that x value by itself. So we want to get that x value by itself. You always want to add or subtract first. You kind of want to start away from the x first. So we have the -9 next to x, but we're actually subtracting that whole thing from 3. So if we can just get rid of this 3 first, that would make it a lot easier to get rid of the 9 later. So I'm going to get rid of this 3. Notice how this is a positive 3. This negative is only associated with this 9x. So this is a positive 3. In order to get rid of this, to move it to the other side, we're going to subtract 3 on both sides. That gets us -9x is less than 27. Alright, so now that we move that 3 to the other side, we followed all the rules. We know that whatever number we have for our x, this -9x, better be less than 27. That's the same thing as this statement up here. We just kind of move that 3 over, so these statements are both the same. But now our goal is to get this x by itself. Same thing as solving an equation. You're going to want to divide both sides by that coefficient, that -9. So we're going to divide both sides by -9. And we're almost done, but here's the one thing that's different about solving an inequality. When you're solving an inequality, if you divide or multiply both sides by a negative number, you see how we did that right there? We divided both sides by a -9. What's going to happen is we're going to actually flip this inequality symbol, and I'm going to show you that in red. It changes from a less than to a greater than. And I'm going to make another video here soon that explains why, that shows you why do you change it, what's the point, why do we have to do this, and why is it only going to happen when you divide or multiply by a negative. But just know that's a rule. This is the only thing that's different about solving inequalities. Other than that, it's the same thing as solving equations. So we divided both sides by -9. Because we divided by a negative, we flipped from a less than to a greater than, and that's going to give us x is greater than -3. And we're going to put that in set builder notation. Set builder notation means the answer is in braces. I'm going to leave a bunch of room here to the left. And you always put a line to divide it. This line is a symbol that means such that. I know for a lot of people that doesn't make a lot of sense. Like, why would you just say such that? It's just an old-fashioned mathematical term. And right here we're going to put our variable. So we use the variable x, so we're going to put the variable x here, so it's going to read x, we're using x, such that x must be greater than -3. So we're going to take our answer, x is greater than -3, and we're going to put it in the number line below. before we can graph it, we have to put it in the number line correctly. And I chose this question in particular because we have a negative here. And I know it sounds silly, but a common mistake when having a negative answer and writing a number line is actually writing the number line in backwards. You have to make sure when you write your number line, your smaller numbers are to the left and your bigger numbers are to the right. So if I put -3 here, the bigger number, the next bigger number going up is -2. So negative numbers, as you get closer to 0, actually get bigger. So there's 0, and then you see we're getting into our positives. Now we can write the rest of our negatives going backwards. -4, -5, -6, -7. So make sure you write your negative number line correctly. That's one of the very common mistakes I see all the time. Now, in order to graph this properly, and I'm going to actually do this in black. In order to graph this properly, we really just need this symbol, this greater than symbol. So I'm going to review with you real quick how to graph. We've got our greater than, our less than, our greater than or equal to, and our less than or equal to symbols. Now, the equal to symbols means that it could be greater than or less than this number, but it is a possibility that it is equal. It is solid. It can be this answer. So we're going to represent that as a solid, or as they say, closed circle. But the other two, the greater than, less than, kind of means, well, it's going to be greater than this number, close to this number, but it's not exactly going to be equal to this number. So we use what's called an open circle to represent something that's not equal to this, but it can get close. So because we have a greater than symbol, it is not equal to. Look at our original question. If there's no equal to in our original, there's not going to be an equal to down here. So we're going to have an open circle on our graph. And it's going to be at -3 because that's where our answer is. Now, looking back over here to how we do this, greater than means we want the greater numbers, the numbers that are bigger. Well, look at your number line. If x represents all the numbers that are bigger than -3, then that has to go to the right. So we're actually going to graph that to the right, or shade it in to the right, depends on how your teacher says it. So that's going to go to the right. But if it's less than, you want the numbers that are less than or smaller than your variable, and it's going to go to the left. So the same thing with these two right here. And one thing that I want to point out that's very important, we could also write our answer as x such that -3 is less than x. I want to kind of point that out. All I did was I took this answer and I wrote the whole thing backwards. Think about it. X has to be greater than -3, right? Well, according to this, your teachers taught you when you were little, oh, the alligator eats the bigger number. X is still technically greater than -3, but this is written backwards. And a common mistake is people say, oh, this is a less than sign, so we have to shade to the left. But that's not the case here, is it? Because our variable has to be what? Greater or less than -3? Our variable must be greater than -3. It must be bigger. So if our variable must be bigger, we still have to shade to the right. Even though it appears as a less than symbol, you have to look at what do all of our numbers have to be. Can this be 0? Yes, it can. That's going to point to the right. Can this be -10? No, because -10 is not bigger than -3. So this is something important that you need to keep in mind for the future.